Hello everybody, we are going to discuss the fresh new topic or subject, that is the statistical mechanics. It is the introductory lecture of the statistical mechanics. What is statistical mechanics? Is the bridge between the microscopic and macroscopic theories. Okay, let's see. What is statistical mechanics? Statistical mechanics is the discipline of physics which uses the methods of probability to analyze the ensemble of the subatomic particles or microscopic object, and it derives the macroscopic properties of the system from its microscopic constitutes. This branch of physics does not postulate newer physics or nature but uses thermodynamics as a base and construct the foundation of the bridge between the microscopic and macroscopic theories. That is all about the statistical mechanics. Statistical mechanics you use the method of the statistics and probability. Why we need statistical mechanics? In physics, there are two kinds of mechanics to be considered. One is the classical mechanics, another is the quantum mechanics. The state of the mechanical system is completely described by the phase point in the classical mechanics and pure quantum state vector in the quantum mechanics. The governing equation for the evolution of this system is the Hamilton equation for classical mechanics and Schrödinger equation in the quantum mechanics. Using two concepts with the state at any other time, future or past, can be in principle calculated, but that is not so easy in the case of practical world. Let's see. Macroscopic objects consist of terribly astronomical amount of microscopic particles, and this is the disconnection between the motion of the teeny particles and daily life experience. So we see that there is huge problem between tracing all the teeny particles which by which all the material body macroscopic objects are constructed, and how the such as heat capacity, magnetic susceptibility, and others property, how to determine these macroscopic properties from microscopic point of view. Statistical mechanics fill this gap by introducing uncertainty about the state of the system and provide the connection between the microscopic and macroscopic objects. So, what is the branches of the statistical mechanics? Classical statistical mechanics, quantum statistical mechanics. This branch of statistical mechanics cooperates with the classical mechanics, and Maxwell-Boltzmann statistic is the classical one. Quantum statistical mechanics is divided into two statistics. One is the Fermi-Dirac statistics, which describe the fermions, and Bose-Einstein statistics, which describes the bosons. Okay, so conclusion. Here I finish the introduction to the statistical mechanics, and we have learned that what is statistical mechanics stand for and why it is needed. Thank you for listening these lectures.